engineering. His career journey includes pivotal roles at OpsTree Solutions, where he built a thriving data engineering team, and Stashfin, where he scaled operations to manage loan and disbursements over like $60 million per month. He's an expert in Kubernetes, Grafana, Kafka, and AI-driven technologies with a proven track record of transforming infrastructure, implementing microservices, and streamlining workflows for faster and more efficient development. Mr. Deepak has also been a passionate mentor and coach, guiding teams across engineering, DevOps, and data domains to achieve the best. An alumnus of IIIT Delhi, he is a certified Kubernetes developer and awardee of Bill and Melinda Gates Foundation grant, and a sought after speaker at conferences and colleges, where he shares his deep knowledge and expertise. Tonight, we are privileged to have him here with us to share his incredible journey, insights on scaling systems, and lessons on mastering modern technologies. Please join me in giving a warm welcome to our speaker, Deepak Kumar Sood. Over to you, sir.
Hi guys. Thanks for that warm welcome, Swati. That was very humble for you. And yeah, welcome guys to the builder session and season one of this night's program. Let's start. So I will keep my camera off so that we save some bandwidth. And so the format is we will start means we will start with an introduction and we will just go through the introduction of what Gen AI is, and then we will jump into the agents if time permits. Otherwise, we will keep on to the Gen AI stuff and along with Q&A. So I will try to keep uh, 15 minutes of Q&A so that everybody, since you are most of you are from colleges, have some ample amount of time to ask questions. And these questions can range from anywhere, so from career guidance to Gen AI to a back end to front end, anything. Cool. So topic is what is Gen AI and how you will master Gen AI. So who am I? So as Swati mentioned, so I started. So I did my MTech from IIIT Delhi, and then I started as a software developer, as most of you will do. Then I quickly jumped into DevOps engineer, then data engineer. Then I led a 50% team at Stashfin as an engineering lead, and currently working as a senior AI data and DevOps architect at OpsTree. Domains, I have worked with multiple fintech companies, I have worked with IoT companies and edtech companies, and currently at my current role, I am working with multiple of these companies along with e-commerce companies also. And along this role, along this whole journey, I have also done product management, project management, leadership, strategy, and hired around 50-60 people throughout my journey. Yeah, and my hobbies are learning. I think that learning hobby as computer science, in the computer science field, you should always have it, because it's changing rapidly and you have to keep on learning new tools and technologies, keep on refining your fundamentals, and have a knack for problem solving. That you should love problem solving, because the whole computer engineering field is about problem solving, and you have to solve that problem once. You don't have to solve problem again and again and again, because we are not an operations guy. And of course, since you will be learning so much, you have to make sure that you keep on notes. I will quickly show you how I keep note, so that maybe some of you get motivated and start keeping notes. I started my note taking after means I joined my first job, but I missed 20 years of my life without note taking. So I would suggest that start early on the note taking journey also. Cool. Since I guess most of you are in means very much new to AI, so we will start with what AI is. So before jumping into Gen AI, so we will start with how we came to Gen AI. What is the background? What is AI? What was before it? And what problem does it solve? And then what is coming up after that? And also we will go into some technicals like prompt engineering. You keep on hearing this stuff. What is prompt engineering? What are LLMs? What are embeddings? How to create a RAG? And then maybe we will have some. I will show you some links around how you can go and do hands-on also. Cool. So how it all? So I'll just pause if you somebody has any question. Otherwise, we will jump right in. Does someone has any question? Yeah, if somebody is shy, keep flowing the questions in the chat also, I guess, and we can answer those later also. Cool. So what is before AIML? So all software developers start with a simple rule-based programming. What is rule-based programming? Simple if-else while conditions. So these are rules-based programming. And so what's the good things with rule-based programming? It has fixed logic and deterministic. It is very deterministic. What you write is what you get. If you write a bug, then it will of course run as a bug only. It will not go fix itself. But if you write the program correctly, it will run forever without any changes. That's what whole computer is about. That once you teach it, means once you write some rules, if else or a computer program, it should run indefinitely. One rule can be like if your attendance is greater than 80%, then you are allowed to sit in the exam. Otherwise, you are not allowed to sit. So that's a fixed rule. That's very deterministic. Key characteristics are static rules, limited complexity. Means it's very easy. Means so you can go and see what is happening. There can be 10 if else, but if you just go through that nested if else or go through the code, you will be able to find that what is happening, and that exactly should will happen. So what were the challenges with the rule based programming? The challenges were the whole thing that it's inflexible. So whatever you have write will run, but it will not go adjust itself based on the environment. So every changes will require manual update. And of course, if the number of rules, this rules increases exponentially, that of course does with a bigger complex problems, then the code becomes very unmanageable. The system grows, and then of course the rule explosion. Large number of rules can make the system cumbersome. Means how you will let's say if you have 10 if else, that's fine. Means you can do. But if there are 10 nested if else, then it's very hard. Means you have to check each condition. Let alone three nested if else is considered as a very bad programming. But if you have 10 or 20 if else, then you will not be able to maintain it. Nobody will be able to maintain it. Lack of adaptability, no learning, limited scope. So these were the challenges with rule based programming. So therefore, to tackle this rule based programming, the whole AI ML came. So one example can be if the image given is a cat or not. So you have given an image. Let's say it's a 64 pixel by 64 pixel image. Each pixel has, let's say, black and white characteristics. So each pixel is 0 or 255, let's say. So now there are 64 by 64 pixels. So there are around 65,000 pixels. So how you can write for each pixel that this pixel should be this color, and based on this color, it's a, so you have to go to a mid section and see if there are face characteristics, or this image has whiskers. So if it's a whisker, then most probably it's a cat. Or let's say if it doesn't have a whisker, then whiskers, then it's a dog. So you cannot write a if else for this many conditions. On 65,000 you cannot do, and that is only for one static image. Cat can be from any angle. It can be from top, it can be from side, it can be from back. So you cannot just write a cat detection or a dog detection program or a classification program using traditional rule based system. So here came the whole traditional AI ML models. So AI is the whole means it's a larger umbrella of how the human intelligence process works, and inside that there is a subset called machine learning, in which we train these models, and this model will be trained on large set of images. We will, so we cannot, so we have came to a conclusion that we cannot write a program for this cat image classification. So what we'll do, we will take 10,000, 20,000 lakh images of a cat from all the angles, and we will give a program to just go and figure it out. Figure it out that what makes a cat. Are those whiskers or a size or color? Based on this, so it will create few parameters. Few, or it can be hundreds of parameters. So what will be a parameter like? Parameter can be one parameter can be if it has whiskers or not. Second parameter can be it if it has four legs or not. Or other whiskers can other parameter can be if it's a small, what's the size. If the face characteristics are like it has two eyes, one nose kind of thing, one mouth, if it has claws in the hands or not. So this all are parameters, or in the machine learning words it's called features. So this we will give this program all 10,000 to a lakh images, and this program will give out these features. That what are the features that are that can be that will be used to detect if it's a cat or not. So this is what a machine learning model is. So what can be types of machine learning model? Supervised learning, unsupervised, and reinforcement learning. So what is supervised? Where we give images of, let's say we are creating, we have to create a model to detect between cat versus dog. So we'll give 10,000 images of cat. We will label each image that this image is a cat. Image 1 is a cat, image 2 is a cat, image 3 has a dog. So we will give this 10,000 images of dog with the labels, and then let's say we have trained on 20,000 images. Now when we give the next image, we have to, the model should tell us if the next image given, that is the inference part, is a cat or a dog. So this is what the supervised learning is, where we are giving the labels also. Unsupervised learning is, now we have given 10,000 images of cat, 10,000 images of dog. It will figure it out. And now when we give the next image, it will tell us if this image is of first category or second category. It doesn't know if it's a cat or dog. It just know this, out of this 20,000 images, this 10,000 images are of cat, this 10,000 images are of dog. It doesn't know it's a cat or a dog. It just know this 10,000 images are of one type, this 10,000 images are of two type, second type. So this is unsupervised learning, and in unsupervised also it's a clustering problem. So one example can be, we have around, let's say we give around 1 lakh customer and tell them that figure out what are the characteristics of this, make this customers, means let's say this 10,000 customer, and create a group of five, classify this 10,000 customer in a group of five. So it will figure it out that this first group of people are maybe younger, this second group are in mid, this third group are in this age. So let's say it took age as a feature and it created 5 groups out of it, something like that. And if, let's say if we gave that, create it in group, 2 groups, then maybe it will create one group of male, it will give one group of female, something like that. So that's a supervised learning, unsupervised learning. Then the reinforcement learning. Reinforcement learning is where the model interacts with the environment and learn from what it has done wrong. So some example can be, you are teaching a robot how to walk. So you cannot tell that walk like this. You will just give it so many examples and it will learn from itself. It will walk and let's say fall after one step. It will know that after, if this is the way I walk, I will fall. So it will try another way. So it will find more and more and more way where it will create the, means it until and unless it achieves the objective. So it will try to fail. So this is how humans also learn, babies also learn. So same goes with reinforcement learning, where it learns by doing, and it takes the feedback of what it has done and then improves on top of it. So these are three major types of models in machine learning. Then key characteristics of machine learning are data driven. Of course, means you have to give large number of data. So if you give 100 images of cat, 100 images of dog, then it will not be a good accurate model. If you give a new image of cat, it will not be able to accurately detect if it's a cat or not. So minimum you have to give a lakh image or 20 lakh image. So huge number of data is required. Then task specific. So you have trained the image model to detect cat versus dog. So it cannot. This model cannot be generalized to do fraud detection. This model cannot be generalized to do reinforcement learning or do a classification problem. So it's very task specific. That what you have given will, how it will work. Then of course, means if it has overtrained, it has undertrained, so a lot of manual configuration is also required. Means so it's not totally hands free. A lot of things has to be done by the developers. So these are the traditional AI ML models that we were running. So what are the challenges? Of course, volume is a challenge. You need a huge amount of data quality issues. So in machine learning and AI space, a major thing, that major proverb that we say is garbage in, garbage out. If you give wrong data, it will learn wrong data. So same goes if you give wrong images of cat and dog. Let's say there are no cat, and you give the image of cat. So then it will get confused. It will learn wrong features. It will give random results. So this is the problem. It has quality issues. So the data should be of high quality. Then task is specific, scalable. So these are not, you cannot create a very generic model to do all the things. It will do only one task specific. Feature engineering, model interpretation. So these are the problems with the traditional AI ML models. Cool. So this is where the new age Gen AI came in. The Gen AI is what? Generative AI. So when you scale this ML model to a very large, where Gen AI models are not something new. These are just the same machine learning models where we have created with the thing that I told, that the code, that where you give a lot of images and then it automatically learns from itself. That code we have scaled it up means in terms of mathematics. So a great paper at released by Google on 2016 or 2018 called the Transformers paper has revolutionized with this field, the machine learning field. And now this machine learning and deep learning model, we are able to scale up to that level where it can do generic thing also. It can do a lot of things. And the number of parameters. So previously, let's say cat and dog model, a model you have created has 1 lakh parameters or 2 lakh or 5 lakh parameters. So we were not able to go beyond that number of parameters because after that the accuracy would have decreased. But now with this new Gen AI things, we are able to create trillions of parameter model. Trillions means, as you know, means this Llama 3 comes with 70 billion parameter model or 174 billion parameter. OpenAI nobody knows, but people say that it has 174 billion parameters. So it has gone to that extent. So this is what Gen AI. So we were able to scale the ML models using this transformer architecture, where we are able to create a very big models. So this is the history of how we came to the Gen AI. We started with a rule based system. Then we, to solve those problems, we came to the machine learning, traditional machine learning and AI models. Now we have come to the generative AI models, and these models are that big that it is not just detecting that this is a cat or a dog. It now generating new cat or a dog. It knows objects and all these things like that. It can generate a cat on a moon where there is no image. You never trained it on an image or image where you sent a cat to the moon and you took that image, but it can generate from itself that this is the moon, this is how the view looks like, this is a cat, how it looks like, and I can generate new things. So this is what generative AI, and it not only can detect images, it can generate images, but it can generate text, music, or of course code also. Cool. Any question till here? Otherwise, we will move to the next section. Yeah, I guess Shrey has some question. Swati, how Shrey can speak? Yeah, you can ask, and Shrey, you can ask the question in the chat box. In the chat, yeah. Yeah, others you can also ask. Priyansh, what were you referring in note taking, like an SPV type, or ways we can fix the note? Yeah, Shrey, I will go towards that last. I will show you how I take notes. That will, of course, help you. Cool. So we will keep on looking on the questions again. But yeah, moving on to the next section. So here we came to the Gen AI. So in Gen AI is powered by LLM. So what is LLM? Large language model. So this huge number of parameter model that we have created is to understand languages. So one part to interact and to create something great out of anything is that model has to understand our human language, because at last that's the communication that we use every day. So this models that we have created understand human language and its nuances. So if you type in ChatGPT, if you type wrong words also, or type a sentence in any way, means you can leave the articles, you can leave the conjunction, and just type something, it will understand because it understands language. So that is the language part. And large, because of course it's very large. So as you know, so as I told, so it has 174 billion parameters. Therefore it's a large language model. It understands language and it's very large, therefore it's called. So some example, of course, you must be using like Chat GPT by OpenAI, Gemini by Google, Llama by Meta and all. Cool. So how we will be working with LLM? So there are three ways we can work with this large language model as a developer. So I will focus on how, as a developer, you can work, how you can use it. So one is of course prompt engineering. So what is prompt engineering? Whatever you are doing. So you are of course asking question to the chat GPT. That is what it's called prompt. If you structure that prompt in a good fashion, it's called prompt engineering. So you have to write prompt in a way that that helps you with your objective or that solves your problem. So that is prompt engineering. So you have to clearly define your prompt. You have to do iterative refinement, and also, of course, you can create task specific prompts. So some example are: summarize the following article in one paragraph. So here you have specified that you want the answer in one paragraph, otherwise it will just ramble around. So you have to give very specific prompt engineering example. So these are some examples of prompt engineering. Then yeah, so the first is the prompt engineering that we can interact with the LLMs. The other two are fine tuning and RAG. So RAG is retrieval augmented generation, and the other is the fine tuning part. So fine tuning is where you train the model on your specific data, and that data should be huge. It should be in terabytes. Therefore, then only you will be able to fine tune the model. It's not like you can give 10 sentence and it will fine tune. So and you fine tune your model accordingly. The other is RAG. RAG is retrieval augmented generation, where what you do is you have your own knowledge base. So this knowledge base can be your own documents. Let's say you have your notes. Those notes are your notes. The Chat GPT is not trained on your notes. So what you can do is you can put Chat GPT, create a knowledge base where you put all your notes, and now Chat GPT will answer all the things from your notes, and doesn't and just say that it doesn't know out of that note. So you have created a means model for yourself without fine tuning, because of course fine tuning and this LLM, if you want to create, require a huge amount of GPUs. As you know, means let's say Llama 3. Llama 3.1 was trained in 64,000 GPUs. Each GPU costs 32,000 GPUs. Each GPU costing $64,000. So it's around 7 to 8 million dollars. So maybe not 7 to 8, most probably $770 million, something like that. So the cost of training this model is very huge. So not everybody has that kind of resource. But creating a RAG system you can do on your laptop. So you don't have to run a or create a LLM. So you can use this means RAG system to just means just use this LLM and your own laptop to create RAG system. So this is how a developer, most of the developers are working with LLM. So yeah, so some of the challenges with LLM are hallucination. So it can give false information. It can give out of date generic answer. Let's say, and non-authoritative sources. So non-authoritative sources, what is it? If you ask a question that means what, how many cigarettes per day a pregnant lady can smoke. So this was a question asked by Gemini, and it answered that 2 to 3 cigarettes per day is fine. But that's the wrong answer, because it was quoting something from Quora, and Quora is not an authoritative source. So it should reference only good sources like medical journals and all those papers that are vetted and all. So we have to make sure that LLMs understand that what are authoritative sources, what are non-authoritative sources. So this will help. So these are the challenge with LLM. It doesn't understand that. So, and of course it can create inaccurate responses, and it doesn't have your data. Means the proprietary information that a company has, let's say Wagoner manual, it is not trained on that. So you cannot ask very specific question regarding Wagoner manual or some book. So some, these are the challenges with element. And of course the solution is RAG, where you bring your own data, you put it into the LLM without fine tuning, and it is able to accurately answer these questions using your data. So this, by this you will be able to trust more the LLM, the chat that you have asked. And of course it will answer your queries. Means it can use organization internal knowledge base. So this is one solution that we can use. So yeah, so one major thing that comes up with all this language system is embedding. So I will just touch on embedding. So it's a mathematical concept. So what happens in embedding is, just think of embedding as a new. So it's a just a number. So at last, see, computer understand number, that is zeros and ones. It doesn't understand language now. So how we trained this large language model to understand language is via embeddings. So what are embeddings? Embeddings are where you have the meaning of the sentences or words you have coded into the this coded into numbers. So let's say you give. So what will happen in embeddings if you give king minus boy? You can do this subtraction and multiplication or addition subtraction in words itself. So if you give a LLM or a RAG model that you have created language model that do king minus boy, then it will give you queen, because it understand that king without a boy means it's a queen, or king plus a girl equals to queen, means you are asking something like queen, because it has understand that queen and king are somehow related. And the numbers, so it's a vector space. So let's say you are using a 164 dimension embedding, so there will be 164 dimensions, and each dimension will be in vector space. And this, in this vector space, there will be one dot for king, means one number of 164 dimension that will represent a king, and one number that is queen. And this king and queen are closer than, let's say, horse is very far apart, something like that. So think of it that way, means that using embeddings in the number system, you are able to code, means teach a means teach computer how the language works, means how king and queen are related, how a boy and girl are related, so that it understand language. So these are embeddings, and it's a mathematical number, it's a just a number. I will show you that how it shows as a number. So yeah, embeddings role in RAG. So what you can do is, whatever, let's say, PDF you have, or whatever knowledge base you have, let's say your university has a lot of information on you, what were your marks, how many days you have attended, what you have learned. So all this text and images and PDFs, all this we can convert into embeddings and store in the knowledge base. And then whatever we do as a prompt will first find the relevant documents in this knowledge base, pick up those documents, and then finally give you the answer. So this is the RAG framework. So whatever, so this is the pre-processing part, where you will take all the documents and all the proprietary stuff that you have, you will generate embeddings, you will store in a vector db. Vector db is just a database where you can store all these numbers, and where this search on the embeddings will be faster. That's all. You can use Postgres also, it's not that you have to use the vector db only. Then whatever prompt you will do, so your prompt will also be converted into embedding. We will search with our existing embedding, so what are the relevant documents related to, so let's say you have asked the question, what is the cutoff marks, let's say what is the attendance criteria for sitting in the exam. So it will go and find those documents. So maybe in some PDF it's written that greater than 85% is required to sit in the exam. So it will, both embeddings will be matched, so that document will be matched with this, that this is talking about attendance, but this document has something about attendance. It will take those document and your prompt and now give it to the LLM, so that LLM has better context and has the proprietary and exact information. Otherwise it will give you a generic information, maybe it was trained on some other university, some other numbers, or maybe it doesn't have any number, it just hallucinate and give you a number. But here with the RAG framework, it is able to bring your documents data and give you the final result. So this is the power of RAG framework. Cool. So as I told you, so there will be a knowledge base where you will store all your proprietary data. Then of course you will retrieve the data, so it's a retriever where you will retrieve the data from knowledge base. You can rank it also. Let's say there are multiple documents that has attendance, so you can rank based on the relevance of documents. So there are few algos for this also, and then generator, so it will take the final document and your question to the LLM and give you the final answer. So these are the components of RAG. Cool. So, any question till here? Uh, I will just read through it. So, Shankar has asked, I've noticed that free generative AI models often struggle with accuracy, ethical concern, even some paid ones aren't. Yeah, training a model from, but just using a pre-trained model, if you want, so if they're better. So, yeah, so the I guess RAG answered your question, Shankar. So, using RAG, you will be able to solve all these problems, and this is what industry is doing. Industry are not training their model because they don't have this much enough data. Your university will not have that terabytes of data na? It will just take a model, create a RAG system out of it, and it is able to provide accurate answer. And yeah, why we are focusing only on Gen AI nowadays? Can you tell me the difference between AI, which have a lot of, no one is gonna, what do you think about AI? Can you really go into Gen AI? So it's a journey, Priyanshu. What I will say means it's not Gen AI or AI or ML. So ML is not going anywhere. Same goes with your traditional rule-based system. Of course, means let's say you have to write a very specific thing. You have to create an API. Let's say you have to create a calculator. You will not use Gen AI to create a calculator. You will just create your calculator using maths and coding. So that will be there. And then the whole ML system, let's say you have to create a very good fraud detection model. So all the fraud detection model now also are running directly on ML systems. You have to create a linear regression model, you have to create a prediction model, you have to, let's say, create a IoT sensors, maybe forecasting model. So these are very good use case for traditional machine learning models. So that's also not going anywhere. Gen AI is create means it has not taken something from others pie. It has increased the pie itself. Means now you are able to do more things where you were not able to do previously. So think of it that way. Yeah, agentic ID is there. Agentic AI is also there. I will just quickly touch through agentic AI also. No, VectorDB is not compulsory, Mayank. You can use a simple Postgres also. The only thing is VectorDB for large scale embeddings are very fast. Let's say you have 1 million to 10 million embeddings. So you can create in Postgres, but Postgres will be slow in that because it's not very much optimized for storing embeddings, and there are multiple search algorithms. Let's say nearest neighbor search. So this kind of algorithms are very fast. You can do embedding search in vector DBs. That's all. Otherwise, if you are smaller, let's say you have 1 GB of embeddings, 1 GB of data, 1 lakh embeddings. So go with Postgres. Yeah, LangChain is famous to build RAG application. Yeah, I will go through RAG more. Cool. So yeah, tools for building RAG. So you have to search, you have to select the right embedding for your use case. There are multiple embeddings. There is a benchmark in Hugging Face where you can see massive text embedding benchmark. It gives multiple embeddings. So you have to choose what embedding is working for you. There are multiple vector DBs. Of course, even Mongo and Postgres also support it. So you don't have to use vector DBs specifically. There are frameworks available: Vertex AI, LangChain, Llama Index. All these frameworks are there for creating RAG systems, so you don't have to write everything from scratch. And then of course you have to choose LLM model which is best for you. So these are the tools. So yeah, RAG is game changer for LLMs. Empowering LLMs, we can create a lot of external knowledge and we can really solve problems regarding this. So this was around the RAG that I wanted to tell. If we have time, we can go through agents also. Otherwise, we can go through questions or some demos. So I guess we have time. Let's quickly go through agents also. I will tell you what agents are because now agents is also in the hype. So I will just quickly go through agents. So yeah. So what is an agent? Key component of a agent, agent versus model, some architecture, and how to build an agent. So yeah, I will just quickly jump right in. So what are agents? So you know what RAG problem is and what LLM problem is. So problem with RAG and LLM is that now they generate things, they give you things, but they don't go and do things. So that's what agent came in, where now, okay, let's say you want that give me a code for sorting, so it can give you a code for sorting, but it will not go and change your code base to implement sorting. Or let's say you want to refactor some code, so it will not go and change your code base itself. You have to do that, and that in refactoring also you have to change few things what AI has given, because it doesn't give you the right thing and change the thing exactly. And then it is a iterative process, because it went and implemented sorting for you. Now there is some bug, now you will copy that bug, paste it in chat gpt, it will give again the answer, you will take that answer, implement, then run it. So that's a loop, iterative loop, and this iterative loop right now humans have to do. So this is now where agents came in, where now it can go and change your code. Let's say you want book a cab for me. Let's plan an itinerary. So ChatGPT will give you an itinerary for Jaipur for 3 days, but it will not give you that go and book this hotel or book hotels on your behalf, or go and book this flight or book this taxi or book this tickets for you. That will not go and do things. So here where agent come in, where it will go and do things. That's what agent is. And it can of course reason, plan and take action. And why reason is required? Because while doing something there can be few errors, so it has to reason why those error came, and then go and change its behavior so that it does that, means it changes that also. So this is what is an agent. So agent will of course observe the world and then act upon it and take actions autonomously. It should be autonomous, it should be proactive, and it should be adaptive, because things can change. So you don't have to go and change everything every time. It should be adaptive to do figure out themselves, because agent is nothing but it is built on LLM. So LLM has the thinking capability, but right now we are asking the question and we are doing the thinking and we are doing the planning. Now using agent, those feedback loops are created into the whole orchestration layer itself, so that we don't have to do it. So RAG is something that you as a developer should work on, learn, and then agent is something that we as a developer should learn. These are things that we have to do, not the researcher. Cool. So key components of the AI agent, of course, the core will be the model. You have to select a model. Then there will be multiple tools. So as I told you about flight or train or buses, so you have to create these tools where you have to tell that there is a flight tool that I have created, flight agent. So whenever you plan that you need some thing where you need to check some flight status or book a flight, go and talk to that agent. So there are multiple tools available with this agent. So there is one flight tool, one is this tool. So yeah, these are the tools. So and then the final orchestration layer, the thing I am saying, that now you have to go and plan from the model. Now you have to go and ask the tools that take that result of the tool and go back to the model. So this whole taking, giving, asking is done by the orchestration layer. So this is what the whole agent is. So there are three key components: model, tools and orchestration layer. So what is the difference between models and agents? So model is of course limited to training data, single interaction, no direct API call, and it generate responses. AI agent extend knowledge with external tools, and this tool can be a RAG system also. So RAG is kind of an AI agent that creates a knowledge base for you, but it doesn't do anything. That's the agent is the extension of that. Multi-turn reasoning, it can do things via different agent. It's not that in a single thing. In the itinerary planning, it will not just only check the flight, it will go check the train also, and then give you the cheaper option, and then once you approve, it will go book it also. So it will be a multi-turn thing. And then also it will be, memory should be there. It means in the halfway through, it shouldn't forget that you are going to Jaipur and book flight for Dubai, something like that. It should do not lose the context. So it should natively integrate with tools and API and then take actions autonomously. These are agents. So some architecture, so yeah, cognitive architecture means first is information gathering. It will collect all the data from APIs, databases, sensors. Then it will reason based on the information. It will reason that now I have this data, how to plan and how to determine the next steps. Then it will of course execute that what I have to do. And then there will be feedback loop. If something failed, that path should be changed based on new input. It will go and find something in Stack Overflow, and it will then change its behavior accordingly. Okay. So there are three main architecture: chain of thought, tree of thought, and React. We will quickly go through it. So we will go for 5 more minutes. After that, we will open for Q&A. Okay. So reasoning thing, chain of thought is of course means where. So I will just quickly go through the example. So Roger has 5 tennis ball. He buys 2 more cans of tennis ball. So and each can has 3 tennis ball. How many tennis ball does he have? If you ask this question in ChatGPT, it will reason like this. If you enable this reason button, so this reason button is what chain of thought is, and this search button is something like a tool. So these are 2 agents or things that are available in ChatGPT. This is a screenshot of ChatGPT. So see how it reasoned. Roger starts with 5 tennis ball. He buys 2 cans, each with 3 balls. So that's 2 into 3, 6. So 6 plus 5 is 11. So it has total of 11. So this is the reasoning capability. So this is chain of thought. Same goes with tree of thought. What is tree of thought? Where there are multiple chain of thoughts. So What is the best move in chess from this position? Move knight. So this is one chain of thought, this is another chain of thought, this is third chain of thought, and based on this three chain of thought, it took the best, that first branch is the best one. So move queen. So sorry, this is the worst one because it leads to check. Third is the best one. So if you move queen, it controls the board. So move the queen. That's the answer. So these are multiple trees, multiple chain of thought you have went through, and you chose the best one. That is three of thought. And then react is something that is the dynamic nature that I was talking. It should be multi-step. So what is the population of France? So first it thought that what is the thought that I should search for the latest population data. So what it will use, it will use a search engine. So that is the action. Now based on multiple search engine result, it will find out that latest data says 68 million. Now is the final answer. So this is the react, that is reasoning plus action. So here it reasoned that it doesn't know what is the latest population data. So and now it has to act. That action is it has to use search engine. So it went through the search engine and brought back the data and then give the final answer. So this is the react framework. These are the step by step. Here explores multiple path. Tree of thought explores multiple path. Interaction with environment is react. So this is it. Means these are different reasoning style. All this material will be of course be available in my blog. I will share all this with you, and of course feel free to go deeper dive into all these things now. Therefore I am going through right this. So yeah, how to build it? You have to choose the LLM model, you have to write the APIs and external tools, you have to make sure memory is integrated and context handling is there, you have to choose the reasoning framework, and then of course you have to create a database. Means it can be database, vector storage, cloud store, and of course here also you don't have to do everything from scratch. There are multiple great libraries available like a small agents, crew.ai, that you can use to create these agents. Cool. What is orchestration that I told? So the whole looping around thing, the how to, where to use tools, go and bring from tools, do the reason, use the model, these are the orchestration. So it will do the planning and action. This is the orchestration there. So this whole agent also, this is a 2020 December or September 2023 paper, no, so 2024 paper that was released by Google. That is everything, and this paper is available here. So this is the white paper. You can go, and it's a very good read. It's not a very dense paper, so you will enjoy reading it through. So yeah, so some code walkthrough, how it will look like. Means I think code is always a picture is worth 1,000 words, same like code also. If you see it, so I installed a small agent, Hugging Face Hub. Then it this creating agent is very simple. Means if you are using a framework, so here I created two agents, code agent and DuckDuckGo search tool. So these are the two tools I am using. I just imported that. I just initialized the agent where I asked to use the code agent. So code agent is the orchestration layer here, and then DuckDuckGo search tool is one tool that we have given to code agent. And now we have asked to the agent, how many seconds would it take a leopard to full speed to run the Pond Art? So Pond Art is a place. So first it has to find out. So see how it reasoned. So search for the length of Pond Art. First it has to go and search, and then it also has to search through leopard. What's the running speed of leopard? So it did the Google search, mean the DuckDuckGo search, and find out the both the answer. And it went through multiple things. And now what's the next thing that it did? So it found out the length of the Pond Art is 155 meter. Leopard top running speed in some blogs or some material it got 58, some material it got 71. So it averaged it. So now agents cannot go and measure and find out a leopard and go measure it now. So it in some blog it found 58 and 71. So it just averaged it to find to a average speed of leopard. And then this was in kilometer per hour, it converted to into meter per second, because this is also in meters. And then finally it came out with a second, that the time it would take for a leopard to run through Pond Art is approximately this second. So this is how it reasoned, and this is just one line of code. This is how easy is to create the agents. And same goes with RAG and all. So using this framework you can go and easily use this. So try it out. Means this is free. Hope everybody knows how Colab works. So this is colab.research.google.com. This is free for everybody. Go and use this Jupyter notebook to run all these things. Cool. So future of AI agent. So multimodal AI agent is the future. Self-learning agent. At last, tools also you have to create. So most probably how to create tools also autonomously, and then agent collaboration, edge AI deployment. So that of course everybody knows that a lot of LLM things, AI is coming into your mobile itself. So that is future where this powerful things will be done directly on your mobile, so you don't need an internet connection and all. So these are the future. So yeah, these are the references, and yeah, thanks. That's about it around what I wanted to tell. So yeah, we will do a quick Q&A. So I will check the questions. Like GitHub Copilot is an example of agentic AI. So yeah, now the newer version of Copilot is, previous version was not. It was just giving you the code related it based on your code. But now in the newest release of Copilot, it can go and change your code also directly. So yeah, GitHub Copilot is one example of agentic AI. Sir, don't you think with advancement in agentic AI in future, our role from managing code will be changed to of course, means roles will be completely changed. But Shankar, I don't know, means if you are a student or a professional, but I would say whatever future is, nobody knows. Whatever you have to do to get a job or get into the next phase of your life, focus on that. And of course, means future is going to be very different from what it is. Jobs will be going to be very different when what it is right now. इसीलिए means learning is one thing that you should focus on. Whatever is coming, keep on learning that. But don't. But fundamentals will be there. See, embedding is something that is fundamental. So you should know embeddings inside out. Frameworks will change, things will change. Therefore, I didn't went through what how to do things, but I told you what is the history, how we reach here. So that are the fundamentals, like DSA. DSA is not going anywhere. Mathematics is not going anywhere. At last, all these things are based out of mathematics and fundamentals. At last, the models that you are creating are at last the code itself. Now, of course, it can be 100 line of code, but behind that 100 line abstraction, also there are thousands and thousands of line of code. So you have to make sure your DSA is clear, data structures and algorithm fundamentals are at least clear. DeepSeek is also in peak. Yeah, DeepSeek is also a new where they are using multiple optimization to, of course, train also, without requiring so many GPUs, and also do inferencing in very less cost effective, where all the parameters, let's say it has 170 billion parameter, but at one time this 170 billion parameters are not active. They are using only 35 billion parameters, and based on what your question are asked, it is engaging those other uh, parameters. So this way they are saving on a lot of GPU bandwidth and all. Yeah, cool. So this were the things. Some Yeah. So this is the future. Sorry, I was not change the tab. I was sharing the code also. So these are the future of it. These are final reflection. These are the white papers, and these are the references for the talk. And thanks, you can use this scanner to join to connect with me. This is my LinkedIn profile, and this is my notes. So somebody asked about my notes, so I will quickly show you my notes. So these are my notes. I cannot remember a lot of things. Means of course, means I have learned so many things, therefore I cannot remember everything. So I have started keeping on notes only. So let's say if I'm learning about LLM, so I start with notes. So what is the introduction of LLM, and all these things that I have done is nothing I have written. So these are just copy pasted things from what where I have learned. So that helps, because now I let's say now I am let's say I'm working I worked on DevOps a while back. So now a new project came where now I have to go and do something in Kubernetes. So I will not start from scratch now. And it's been, let's say, 3 years I have worked on Kubernetes. So I will not go and start from scratch. I have my kubectl commands. So that how to do watch, how to do restart the deployment, how to run a small container. So this is what I was doing when I was learning Kubernetes, or I was working with Kubernetes. So these are my notes, and this is where from I have learned. So therefore, when I again have to work on Kubernetes, I will not be starting from scratch, or let's say from Ansible. So I have few commands that I worked when I was working in Ansible. So if I have to again work on Ansible, so I will not start from scratch. So therefore, I would say note taking is important, because in today's world you are going to do a lot of things in lot of different tools and technologies. So you have to make sure, and tools and technologies change, like in front end. If you go with front end, there are a lot of things that are available. Means let's say JavaScript is there. Then if I go to framework, so there are this many frameworks. There is jQuery, React, Preact, Angular, Vue, Ember, Polymer, Backbone. So there are so many frameworks. So in some project you are working with Angular, some project you are working with React. So you should have your notes so that you can quickly go and reference your notes, and you don't have to start from scratch here. Means try to keep notes. I have been keeping notes. Let me just show you. So this notes is very much big, and it took around 8 years to build this. So it has around 2500 files, and it has around 281,000 lines of things, means lines of text in it. So that's a huge amount, and it was not built on one day. It took 8 years. So I would say start taking these notes. I use Docusaurus to take this live. This is live in my website, but you can use instead of Docusaurus, means I use Docusaurus and Obsidian. Obsidian is my note taking tool, and Docusaurus is my note publishing tool. Everything is available in my GitHub open source. You can just use that. Means if you want to use this framework. But I started with OneNote. I switched to Docusaurus with Obsidian after 3-4 years. I would say start with OneNote. It's very simple, because first thing is you have to make a habit of writing. If you are taking a very hard tool, then maybe you will get demotivated, and it will not become a habit of note taking. So start with Evernote or OneNote. I use Google Keep also for few of my notes. So whatever is helpful, start with those, and then means note taking is important. Tools and technologies are something not very important. You can use anything. Cool. So some questions again. Any more questions? Yeah, I can share my notes and everything. So this is my blog. Uh, and then and the presentation and everything is also available here. I will just give you the link for that also. So this has all my meetup links, talks, and sessions, and it has all the presentation. Cool. Any other question? One, I guess, question Dev Priyanshada. Data science, machine learning, deep learning is sub part of Gen AI. It's essential if you want to build AI. Yeah, if you are let's say RAG, if you're building RAG, you should know fundamentals of RAG. Same goes with agent. But if you are building LLMs or deep learning models, then you have to know the fundamentals of machine learning, data science, what is a classification model, how linear regression work, how logistic regression work, what are different kinds of models. So let's say in machine learning also, the I cannot remember things. So if I go with machine learning part, so there are lots and lots of machine learning algorithm. What is a linear discriminant? How do you do linear discriminant analysis? How to do classification, clustering? What is the decision tree? What is k nearest neighbor algorithm? So these are few of the important. Let's say you are working with deep learning. So let's say I have written something on deep learning. So let's say what is a generative adversarial network? What is GNN, graph neural network? So you can go and read about it. So there are a lot of things in now predictive analytics. So if you're working with IoT things, so predictive analytics is something that is very much required. So these are the fundamentals, and these are the final mathematics that you have to do. So yeah, these are the things: embeddings, estimators, what are vector embeddings. So these are the fundamentals. You cannot go around it if you are going inside. So yeah, cool, cool. Any other question? Anybody? Anything? Yeah, over to Swati then.
Okay. Thank you, sir, for your outstanding presentation. We are grateful for your participation. Please take a few minutes to complete the questions that I'll be asking. So, can you share the pivotal moments in your career that shaped your journey as a senior AI data and DevOps architect?
Cool. So that's a great question, Swati. I would say most of the things that I did was luck, and in that luck, most of the things was just saying yes. So let's say somebody told me go and do this DevOps. I never applied for any DevOps job. uh, there was some problem statement that came in. I was working in a startup, so you have to work or you have to take on multiple hats. Somebody told me just do this. I said yes, and I didn't knew how to do it. I just go and read about it. And you that time there was no chat GPT. Now you have chat GPT also. So never say no. You will get lot of opportunities, and say yes, do your level best, and tell that this was the best that I could have done in this amount of time, and then you will do great stuff. Means that's the only thing that I want to say, Swati.
Rightly said, sir. My next question is, as someone who has led large teams, what strategies do you use to foster collaboration and innovation within your teams?
So yeah, great question there also, Swati. So see, management is also something that I was never asked for it. Means I never went and did MBA and anything. So it was like a small thing that I was working very good. So new interns came in. So they told me that try to use this intern to do more. If you go into upper and upper management, the things that happen is now you have to do same thing 100 times. Means you have to scale up yourself. Means you were writing code, let's say you were building one product. Now at an upper management position you will be building 10 product, and now you cannot build 10 products now. So you need 10 teams where you will manage those teams, and those 10 teams will build the product. So there of course you have to learn about people management, project management, product management. So this is how I learned. So this is I went and researched how to do people management, how to motivate, how what is culture, how to do mentoring, different types of leadership. And then you have to understand people also. Means this is how you will learn. Go and learn from the best, go read some books, go watch some videos, and then keep open minded. Don't say that I will not do this, I will not do this. And also had so many problems. Like one problem that I had when was the first time I went to the stage, I got blacked out. I knew I had stage fear. So I didn't fight myself that no, I have stage fear, I will never go. I knew that it was a problem, and the solution, I searched for that solution, and the solution that everybody was saying is go and do this more. It's fine if you blank out, but go and do this. And over time I learned how to present and how to speak to a larger audience. So don't fight yourself, go find out what others are telling, and then try it. Means of course I could have failed, then I would have found out other ways also. So it's an iterative process, you have to go and learn. And same goes with people and team management. See what works for you, what kind of leadership you are. So there's many different types of leadership. And then see what works for you, what works for your team, and go about it.
Well, I must say, stage fear is the pretty common thing. And on that note, winning is not everything, but one should attempt winning. And as you said, it is very important to take forward your team members, make them feel inclusive. And for that, you need to have like the synergistic personality to keep everyone think like, yes, they are a part of team, they will be working. So one more question, I won't just take your much time. Can you share a memorable project or achievement that you are particularly proud of and why?
Cool. So there are two projects that I'm particularly proud of. One is the Bill and Melinda Gates Foundation. That was one of my first project that I did in my MTech. So BTech I wasted. The 4 years of BTech I was from a third degree college, and that college got closed also. So I just enjoyed my BTech. I never learned because nobody was there to motivate us. And there was no YouTube also at that point of time. Not a lot of YouTube, so there was no motivation. Everybody was playing. I was also playing. But when I went to MTech, I understood what computer science is, and then I got motivated. Means computer science can really solve problems and really solve bigger problems like UPI. Means can you imagine sending money by going to bank now? Means you cannot go and send money to the bank. Means how 140 crore people are going to do that? No, it cannot. It is not possible. So computers, using computer and using this technologies, we can solve real world problems. So therefore I got excited. Yeah, so this has the larger impact. What I am doing has larger impact, and that's when I went and studied everything. So the one project that I did was so it was a PhD researcher project. I was the main developer. So we created a mobile app. I was the Android developer and backend developer also. So we created a mobile app to for ASHA workers. So this ASHA workers go to pregnant people, ladies in villages where they don't have access to mobiles or doctors, and they use this feature phone to just call a doctor. Means not call a doctor, there is conference. So a doctor will create a conference, and this ASHA workers will go to, let's say, 50 ASHA workers will go to 50 places, and this 50 places there will be 10 mothers or people sitting in, and then doctor will give you a lecture. They don't have laptop or Discord server for conferencing now. So they use this feature phone on loudspeaker, and doctor is doing the means telling the means giving the lecture that what is the right way. And this feature, using this feature phone, they are listening in. And then the best part is they can use this feature phone to ask question also. So if they press one, they can ask question, then they will be unmuted, so that not everybody is speaking. So it's a group conference feature of people like this Discord and everything for cheaper people. Means for cheapest possible way. Means they have feature phone, only loudspeaker, no web, no nothing, only doctor has the smartphone, nobody else has a smartphone. And this was awarded Bill and Melinda Gates Foundation awarded $10,000 for not 10,000, sorry, $100,000 for next phase of this project. And I was the developer there, and I was really proud of that. This is the one thing. The other thing is that Stashfin, it was a fintech company. So when I joined it, they were doing only 5 crore of dispersal per month. There were a lot of problems, and these problems were around culture. They were not listening. They were resisting themselves. Their database was not performing. Their DevOps was not performing. Nothing was performing. So when I went, everything was in mess. But when I left after 3 years, they were doing 500 crores per month, just because I resolved all their problems, people problem. I hired my own team, I solved all their DevOps problem, everything was very smooth. And this all we achieved without spending money. So we were, when I joined, they were doing $45,000 of AWS cost per month, and with 5 crore of dispersal. But when I left, they were doing 500 crore of dispersal with only 20,000 USD of AWS cloud bill. So that was also a achievement that I'm very much proud of.
This is like you are going from scratch to hatch.
Yeah.
And so your input is invaluable to us. Thank you for joining. And this was a mind blowing session. I hope all the participants must have enjoyed it. And we would love to interact further.
Sure. Thanks, Swati. Thanks, everybody. You were great audience, and thanks, Builder Space and the whole team for arranging this session. Thanks. Feel free to reach out me on LinkedIn or my socials for any other further questions and all, guys. Thanks a lot. Have a good night, guys. Bye.
Thank you everyone for joining us. We will be wrapping up the session right here.